Now, that is load balancer in general. Now, Azure load balancers. There are different options to distribute network traffic using Microsoft Azure. Okay, so in Azure also you've got the same. You've got load balancing as a service, so that you can have multiple servers in the backend, and those servers are connected to load balancer, and load balancer will handle the traffic. Okay, so there are different options to distribute network traffic using Microsoft Azure. Whenever you see network traffic, that means it is a layer 4 load balancer. Whenever you see application traffic, that is a layer 7 load balancer. Okay, so these options work differently from each other, having different feature set, supports different scenarios, and they can each be used in isolation or in combination. That means you can use layer 4 load balancer separately and layer 7 load balancer separately, or you can put them together and you bring a more complex application environment as well. I mean, you can address more complex scenarios as well. So you've got Azure Load Balancer, Application Gateway, and Traffic Manager. And there is a new one added called Front Door. So there are 4 different options available: Azure Load Balancer, Azure Application Gateway, Traffic Manager, and Front Door. For the day, we are talking the first option, Azure Load Balancer. So what is this Azure Load Balancer? Azure Load Balancer is a managed load balancer service that Microsoft provides. You see, it is a managed load balancer service, meaning you do not have to install, configure. Microsoft does it. You only pay for what exactly you use. I mean, you pay for number of hours that you keep it on. Rapid elasticity. You just can have one load balancer or 10 as you wish. Broad network access. You can access it from anywhere. So all those 5 essential you can add here as well, and you can bring out a lot of definitions. Load balancer supports both inbound and outbound scenarios. That means for incoming traffic, and from your account to the external world also, you can have the load balancers configured. So that provides a very low latency, high speed traffic based applications, and you can scale up to millions of flows for all TCP and UDP applications, because at layer 4, it is TCP and UDP, the protocols that you can use. At layer 7, it is HTTP or HTTPS that you can use. Okay, so we can use load balancer with incoming internet traffic or internal traffic across Azure services or port forwarding. So these are the 3 different scenarios that you can use Azure Load Balancer as. The first one is internet traffic. So the same scenario that we've discussed. You have multiple servers in the backend, you have a load balancer, register them, you publish it on the internet, people on the internet can access it. That is the first one, internet-based load balancers. Internal only or internet traffic or private load balancer means you have virtual machines, you have load balancer, everything is accessible only inside your virtual network. Normally what happens is in a very complex application environments, you have the first layer, right? These are your web servers, right? This is internet and people on the internet will access them. So this is your web tier, web servers. The second layer is you will have again a bunch of servers. This is application servers. So just like how you have got your web servers, you can have your application servers. So there you will have another load balancer. So these web servers, obviously they wanted to talk to your application layer. That's where, so this part, normally what happens is, right, behind the blue will be inside your VNet. Inside your VNet, right? And one that is in orange is like, that is accessible over the internet. So this load balancer that you see here is internal, a private load balancer. This load balancer that you see here is public load balancer that is accessible on the internet. Okay, so that is the second scenario. Port forwarding is something that we will see tomorrow, because part of the virtual machine scale set or auto scaling, we're going to use that port forwarding as a scenario, right? So Azure Load Balancer supports 3 different scenarios. 1 for internet-based traffic, 2 for internal only or private load balancer scenarios, 3 for port forwarding. So when you're manually configuring a load balancer, what you normally do, you have either a virtual machine or a physical machine. Inside that, you will have to install the load balancer, right? Install the load balancer application. And then that virtual machine availability, that virtual machine will also fail. So availability of that load balancer, capacity of that load balancer is all handled by you. And you'll have to do a lot of maintenance activity as well. So instead, if you use Azure Load Balancer, there is no infrastructure, no software that you maintain. It is all done by the provider, Microsoft. That's the reason we call it as it's a managed service, right? So if you see this diagram, this is one of the examples, like I said earlier. This first part, right? This is a public load balancer that is available over the internet to the users. And this web tier, you see, is talking to the application tier here. So this is a private load balancer. This is only available inside the VNet. This is also a private load balancer. This is also available only inside the VNet to another layer of applications, right? So that way you can have multiple layers of the application and each layer talking to another layer of application. And you obviously need a VNet between, you obviously need a load balancer in between. But a load balancer, if it is connected over the internet, that's when it is called public load balancer. The load balancer uses hash-based distribution algorithm, like the most load balancers does. It uses a 5-tuple hash information. So do you remember that we've used this word 5-tuple hash? Anybody remember this? Based on the source IP address port number, destination IP address port number, and protocol. These 5 pieces of information. Do you remember that we've used this? Networking. Yes, when we were configuring when we were configuring security group, network security groups, you write those firewalling rules based on these 5 pieces of information. Okay, so whenever traffic is coming from, it uses these 5 pieces of information. What is that source IP address at port number, destination IP address port number, and the protocol. Using these 5 pieces of information, it does the load balancing. This provides stickiness within a transport session, meaning that packets in a same TCP or UDP session are redirected to the same instance behind the load balancer. That means, especially in a e-commerce based web applications, right? E-commerce based web applications. What will happen? Assume that this is server 1 and this is server 2. And this is a load balancer to which you are connected. That's good. And you are a user. You hit a URL, Amazon.in. So when you hit the URL for the first time, your connection went to the first server. You added 4 items to the cart. While you are about to check out, there is another item that you've liked. You said right click, open in a new tab. So when you say right click, open in a new tab, that will go as a new request. If that session goes to the server 2, then in the tab that is connected to the second server, you will find the cart information is 0. In your cart, you will find 0 items. But if you open the other tab that is connected to server 1, then you will find 4 servers in your profile, in your cart. So that inconsistent information is because that cart information, this profile information is stored much in the session itself. That's the reason, based on that 5-tuple hash information, based on the source IP address port number, if it understands, if load balancer understand, okay, the second request is also coming from the same user that who already connected to the first server. So the second request, third request, even if it is 10 or 100 requests, all the requests of a same user will go to the same server. That way, there will be no inconsistency of the profile information. You see, I think if you understand this, there is a famous dialogue in one of the Telugu movies. It's Allu Arjun movie, Son of Satyanarayana. In the second of a movie, there is a situation that Brahmanandam comes to villain's home. ఇంత గింజలో అంత మర్రి చెట్టు ఉన్నట్టు something he says. I mean, there is a small sentence, but the explanation is, is so long. Similarly, it's a small line, but then you understand there is a scenario that I've explained you. The reason I'm spending time in explaining you this movie scene and all is because so that you remember it and you recollect it very quickly if you have to explain this in the interview, right? That 5 triple hash information gives you that stickiness within a transport session. That means same sessions, I mean, multiple connections from the same user, same source IP address will be connected to the same backend server. You have control over how inbound communication comes into your endpoints. Okay, so that's about your load balancer. There is a course in our website at cloudcourse.in. In self-placed, there is a course called Comprehensive Guide to Azure Load Balancing, which is a free course. So this gives you a very basic understanding for you to get started with any load balancer, any cloud-based load balancer.